So we are using the matrix approach to resolve this. Okay, so we still have the same answer. As we approach it with other method, we still have the same results. So let us approach this with matrix method. And how do we do this? In solving this simultaneous equation to determine the value of x and y. Okay, so let's start with the first set of equation. Let's say this is equation 1, equation 2. So for x, I have my coefficient to be 4, and y I have to be 7. Here I have to be 3. Coefficient of y is 1. Okay, so here the two variables I'm working with is x and y. So I have it here, x, y equals, my result here is 20 and minus 2. So when you look at these rows, okay, you multiply with this column, you still have this 4 times x is 4x plus 7 times y is y, 7y equals 20. And when you take this down row, multiply with this column, you still have this 3 times x is 3x plus 1 times y is this equals minus 2. It's still the same thing. So this one is just the matrix representation of these two equations. Okay, so from here now, what we do now is we can label this matrix here, this as matrix A. So let us say this one, let A represent this. So we have 4, 3, 7 and 1. Okay, when A is this, so we can write this as A, okay, times xy equals 20 and minus 2. Okay, it's like you write this as this. Okay, by changing this to A, repeat this back, equals 20 and minus 2. So the next thing is for us to look for the inverse of this matrix, inverse of matrix A. Okay, and to determine the inverse, we have to know the determinant of this matrix. Okay, and do not forget this inverse we are about to look for, we are going to use it to multiply both sides of the equation. Okay, so let us use this inverse, which is this, to multiply this side of the equation. We have inverse of A times A xy, and we have here this same inverse. Use it to multiply this. We have inverse of A times 20 and minus 2. But I want you to take note of something. We have inverse of a matrix multiplying by itself. So inverse of a matrix, inverse of A multiplying by A, we have identity matrix. This one is out. So here we have x, y equals, so let us determine the inverse of A. So how do we do that? To determine the inverse of A, we have to determine the determinant. Okay, determinant of A first. So to determine the determinant of A, okay, we have to come back to the matrix, which is A. A represents this. We have here 4, 3, 7, 1. Okay, so determinant of this means multiply this diagonal together. 4 times 1 is 4. Okay, subtract this from this, multiply this together. 7 times 3 is 21. So when you say 4 minus 21, you have minus 17. That's determinant. Okay, so to now determine A inverse now. Okay, so we have it to be 1 over minus 17. Okay, into, so for this, in this case, you interchange this. So 1 will come here, 4 will come here, and you look at this next diagonal. Okay, you interchange the sign, just the sign, not the number. So we have positive, positive, so it turns to negative 7 minus 3 in this case. So this inverse of A. Okay, but you can as well write this as, if you open up, okay, we have to be 1 over minus 17. When you times this with this row, okay, and when you take this with this, you have this to be minus 7 over minus 17. Okay, and when you take this, you have here minus 3 over minus 17, or you say 4 over minus 17. So either of these two, you can use it and bring it back here. Okay, so now for this, we have, when we resolve this, we have just we have here minus 1 over 17. Okay, here minus cancel minus, we have 7 over 17. This cancel this, we have 3 over 17, and here we have minus 4 over 17. So let's take this as our inverse of A. So when we now come here, we have this, multiply it with this. Okay, so for inverse of A, which is this, we have minus 1 over 17, 7 over 17. Okay, that is the first row. The second row, we have 3 over 17, and here we have minus 4 over 17. Okay, so from here now, we multiply this, which is the inverse, multiply it by 20 and minus 2. Okay, so our result here will determine x and y. So for the first row, we multiply the first row with the first column. Okay, so how do we do that? Sorry. So from here now, we have minus 1 over 17 times, okay, items on the column here is, the first one is 20. Okay, add it, take the second one and multiply it with this. We have 7 over 17 times minus 2. Okay, so come to the down row, take this and multiply it with this. We have 3 over 17, okay, times 20. Add it up with the next one. We have here minus 4 over 17, okay, minus 4 over 17 times minus 2. Okay, so here we have it in the brackets. Okay, so when we open up this, we have 1 times this is minus 20 over 17 plus, so here we have minus 7 times 2 is minus 14 over 17. Okay, for the first row, and for the down row, we have, when we multiply this, we have 60 over 17. Okay, plus here we have 4 times 2 is 8 over 17. Okay, this is minus 4 over 17. So from here, we can easily determine our x and y. Okay, which is this equals, okay, sorry, here we have x, y. Okay, so for x, we have, when we resolve this, we have minus 34 over 17 for the upper row. For the down row, we have this to be 60 plus 8 is 68 over 17. Okay, so when you divide this, you have this to be minus 2. When you divide this, you have this to be 4. So that means x equals minus 2, y equals 4. So using the matrix approach to resolve a simultaneous equation, so when you take this and you substitute back to any of this equation, it must equate 20. Okay, and this must equate, so let us try equation 2. So for x to the minus 2, we have 3x plus y equals minus 2. So let us test it. So we have, let's verify it. We have minus 2 times 3, okay, plus my y is 4. So minus 2 times 3 is minus 6 plus 4. I have here minus 2. So that means the value of x and y is correct. So you can check this and check it in equation 1 whether you have 20, and drop your observation in the comment section. Thank you very much.